We continue with the similar problem. Okay, this is part 2 of how you calculate from the simple 2 degree of freedom system. We have calculated the natural frequencies. Now we want to calculate the mode shapes. So very easy. You just look at this first equation. Alright, so you are looking at the first line of equation. So let me write that. It's actually negative 4 omega square plus 30 times x 1 and then minus 20x2. So just take the first one and you rearrange it in terms of x2. Okay. So when we actually want to calculate the first mode, is basically you have to evaluate at the first omega 1. Okay, so we already have this general equation. So you substitute your x1 equals to 1 and then you solve for your x2. So as shown here, we already put the omega value. So what's the main difference is the omega value. So at omega 1, you substitute 1.8124, okay, which we have calculated earlier. So you get 0.8430. Then you do the same thing, okay, using exactly the same formula. So now you just change, instead of the first natural frequency, you are looking at the second natural frequency using exactly the same equation. So you get another value. So both are evaluated at x1 equals to 1. So the way to write your mode shapes, so this is one of the form. So you write exactly x1 and x2 evaluated at the first natural frequency. So x1 is 1, x2 will be 0.8430, and the second one is evaluated at the second natural frequency when your x2 is negative 0.5930. Alright, so that is the final answer of your mode shapes. There are some questions, maybe they would ask you on the ratios. So very easy. Sometimes they ask you on the ratio of your x2 over x1 or x1 over x2. So you just use that value and divide it through. So no worries. As long as you can show the relative value between x2 and x1. Alright, so that's all for all the steps. So the whole problem, we have done all the steps 1 through steps 5. Alright, okay, that's all. Thank you.